Hello everyone. In this lecture, we are going to discuss demultiplexers. In the previous lecture, we have already talked about the multiplexers, right? So let's see few of the fundamental properties of demultiplexers. The properties like it is just perform the reverse operation as mux. So in multiplexers, we have already seen multiplexer have 2 to the power n inputs and generate one output. So there are inputs we have in 2 to the power n and it generates single output, right? So here I am saying inputs and there are outputs. So this is mux. In case of demux, it performs the reverse operation. So it has single input. Let's say this is demux. It is having single input and it will have 2 to the power n outputs. Okay. So this is demux, demultiplexer, right? Now the third point is it is derived by mux by joining all the inputs together and removing OR gates. So I guess you remember that. Let's say if you consider a mux which is 2 cross 1. So there are two inputs. Let's say I0 or I1. And there will be one select line, maybe S0, and one output like Y. So the expression of Y we will write something like this. Y will give with S0 bar we will get I0, with S0 I1 will be received. If there is enable line also you want to consider, then you can perform the ending with enable line. So that is this, right? Now once we do this, we can draw the circuit. So there will be two AND gates, right? So if I assume that there are two AND gates and it is taking these inputs, there's another AND gate, it is taking these things. If there is enable also we can take that, and there is after this there is an OR operation which will generate this plus, right? OR operation, and then we will get Y. So let's say we assume that this is S0 bar and this is I0, right? And this is S0 and this is I1. So this circuit will generate or realize this Boolean expression. Now in case of demux, demux will have one input. So in case of demux, what we are saying in this third point, that in case we join all these inputs, so in case we join this I0, let's say I'm joining this I0 with I1, so there is only I1 input, right? And we are removing this portion, we are removing this OR gate. So we will have two output here, this one and this one, right? Select line is one only, so this will look like, if I draw, it is demux. There's one input and there are two outputs and there's one select line like S0. So this is I0 you will get here and I1 you will get here based on your input which you are getting here. Okay, so I guess third point is clear. Mainly used to construct switches. So because one line it can transfer to n number of possible lines, it works as a switch. Demux is used at receiving end and mux can be used as transmitting end. So the meaning is, let's say we are having a multiplexer. So let's say 4x1 multiplexer. If I am taking, there are 4 inputs and there is 1 output, and there are 2 select lines, right? Now this line can be transferred and we can use here demux. So at receiving end, the demux will receive this signal which it is getting, and it will convert into the possible output based on the select lines here. So this is mux, which is transmitting the things, and this is demux, which we will utilize to receive, right? So let's look at demux in detail. So let's say this is the circuit representing demultiplexer, and that demultiplexer is 1 cross 2. So I'm writing here 1 cross 2 demux, sorry, 1 cross 2 demux. Here it is a select line, so you can take it like S0 or S. This is I, and here you are getting, either you can say I0, I1, or you can say Y1, Y2, or Y0, Y1, whatever you give that, right? So these are the output of this demux. Now if you want to write the Boolean expression for it, I'm taking here enable line also. So let's say this is E. If E is 0, this circuit will, Y0 and Y1 will be 0 only. If E is 1, based on the value of S, this I will be connected either to Y0 or Y1, right? So if we draw the truth table representation for it, so based on the value of E as well as S0, we decide what ultimate outcome we will get. Let's assume that we are having a table like this. Okay. Now in this, we are taking few things. So let's say we are taking enable, E, and S0. Based on this, we are getting like Y0 and Y1. So Y0 and Y1 output we are writing here. If E is 0, this S actually become don't care, both this value we will get 0, right? But in case E is 1, then there are two possible values of S0, either it can be 0 or it can be 1. So if E is 1, then based on this value we will get value here. So if it is 0, we will get I transferred to Y0. So this I will be transferred to Y0, right? So Y0 will get I here in this combination, but Y1 will be 0 here, and Y1, when S is 1, then Y1 will get I transferred to it. So in that case, this will be connected, and here Y1 will get I means input, right? So if we try to write the expression of Y0 and Y1, it is not very difficult. So Y0, actually Y0 we are getting I here. So this is E dot, this is S0 bar, and here we are getting I, so we will write, right? Similarly, we can write the expression for Y1. Y1 when E is high, so E is there, enable, then S0, and then we are having I. So these are the expression, and for this expression we can easily draw the circuit. So the circuit will look like, there will be one single input, that is I, and this finally we will get by having AND gates. So let's say I am having two AND gates like this. So this AND gate, let's say it is 3 input AND gate. So there are 3 lines, 3 input lines. This is also 3 input AND gate, let's say. There are 3 lines. Here if we are getting E, this thing as E, and this thing, let's say we are getting like S0 bar, and here we are getting I, right? Based on that we will get here Y0, right? And similarly here, if we are getting E here, S0 here, or I, then we will get here Y1, right? So this will give us this. This is having only single input, so I can draw the input like this. So if there is a line, let me clear it, something like this. Let's say there is a line, so this line is there. I'm drawing something like this. This is, let's say, having value I input, and there is line which is coming as S, and this will represent S bar for me. So I'll put NAND gate here, or NOT gate here, like this, and I'll connect this thing with this like this. This is the NOT gate. So in case I'm mentioning here, this is S, this will give me S bar, this line will give me S0 bar, this is S0, let's say, right? And this is I am considering I. So this I is being connected here, this is connected here as well as here. So single input is coming, right? This S bar is connected here, from here, this line, right? And this S0 is connected from here, so you can assume that this line is getting connected here. Enable line you can have, so enable, you can connect one line as enable line, and you can connect these. So this will give us the circuit of demux, right? Similar thing we can draw for 1 cross 4 demux. So there are multiple demux, and the select lines will be, so if the demux is, let's say, 1 cross 2, 2 means 2 to the power 1, so this power will represent the select lines, so number of select lines. If it is 1 cross 4, 4 means 2 to the power 2, so there will be 2 select lines. 2 select line, I am writing SL select lines. If it is 1 cross 8, there will be 3 select lines. If it is dot 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 1 cross 2 to the power n, then there will be n select lines. So it is exactly just reverse circuit of multiplexers. Okay, so with this I am closing this. Thank you everyone.